Good morning. This lesson is for my Integrated 1 class, but before I get started, I want to say that I hope that everyone is doing all right out there. I don't know what the title of this lesson is. It might be Unit 6, Lesson 5. I don't know. I'll title it correctly in the title. But what I do know, tongue twister, I'm going to say this right one time. But what I do know are what our 3 goals are today. Let me put it, I need to learn how to count too. I'm having a hard time. All right, I can do this. You can do this. All right. So our first goal is going to be to review congruent and define bisect. Our second goal is going to be to bisect a segment and create equations. Our third goal is going to be to bisect an angle and create equations. So let's start off with our first goal and review congruent, or this is our symbol for congruent. And congruent means it's the same shape and the same size. So I have 2 examples I want to talk about. I want to talk about segments and angles. And so if segments have equal length, they are congruent. So here I have 2 segments that have equal lengths. And so watch how I write this out. I'm going to use some ideas that we've seen before. We know the length of segment AB is equal to 7. We know that the length of segment CD is equal to 7. By the transitive property, transitive, I can spell, I can do this. By the transitive property, since both of these lengths, or both of these segment lengths are equal to the same length, both of these segments must be equal. The length of segment AB must be equal to the length of segment CD. So if I have segments with equal length, they are congruent. So I can say that segment AB is congruent to segment CD. We use this symbol when we talk about congruence because we're talking about the object. There's no mark here because we're talking about the number. So make sure we're aware of that. All right. Now, since they're congruent, since segment AB and segment CD are congruent, we can add a congruent mark to the segments. This is a way to show congruence. I'm repeating myself. This shows us congruence here. So the congruent mark's really easy to identify. So I put a little red mark there and a little red mark there. I've said that they're congruent, and so since they're congruent, I can conclude they have equal length. All right, so let's move on to the next part. We're going to talk about angles. If angles have equal measure, which means they open the same amount, they are congruent. So again, I have 2 objects that have the same measurement. They're opening the same. So I know the measure of angle F is 30 degrees. I know the measure of angle G is 30 degrees. Since 2 things are equal to the same thing, that implies those 2 things must be equal. So the measure of angle F is equal to the measure of angle G. All right, and since I have equal measures, that implies that the angle F is congruent to angle G. Now, just like before, we can add a mark to show congruence. We can add congruent arcs. And this shows congruence or equal. I'm looking at the wrong camera here. I need to look at that camera. I got 2 cameras going on here. All right, so we can add congruent arcs. Okay, and so if I see these marks, which are called arcs, I know that my angles are equal or congruent. So let me go ahead and clean all of this off. I'm going to bisect the segment, and I'm going to create the equations. Actually, I need to define bisecting. I still need to do that. So let me clean this up and I'll be back. I'm back. So let's go ahead and continue with our first goal. Real short, just define bisect. Bisect is to cut in half, or it's to cut into 2 equal or congruent parts. So I'm going to check off our first goal. All right, our second goal is to bisect a segment and create equations. So I have an example here. segment JK, no, seriously, segment JK is bisected at point M. So, again, when I say bisected, I'm saying I cut in half. And so let's explain what this means. What does this mean? What does this mean? Well, I can say that the length of JM is equal to the length of MK. That's one thing I can say. All right. I can also say that segment JM is congruent to segment MK. I can also say that point M is the midpoint of segment JK. No, seriously. I just have to make myself laugh. Point M is the midpoint of JK because that is where it's cut into two equal parts. Or that is where it's bisected. Where JK, no, seriously. Alright. So point M is a midpoint. I can also write the segment addition postulate, which would be the length of segment JM plus the length of segment MK equals the length of segment JK. No, seriously. So there's a lot of information that comes from the word bisected. So look at all this information that just comes from that word. All right, so I have a second example here, and this one starts off with a picture. Okay, this one starts off with a picture. And so maybe hit pause and figure out what you can say about this. All right. And hopefully you did. And if not, do it now. And then hopefully you did again. And as I look for my marker, which I hid somewhere, I don't know, there's a marker. Let's see if this one's any better. So I'm back. So what can we say about segment RT? Well, first thing I can say is we have congruent marks, right? And since we have congruent marks, that means that the segment RS must be congruent to segment ST. That also means that the length of segment RS must equal the length of segment ST. That also means that point S is the midpoint of segment RT. And finally, if I wanted to, I could also write the segment addition postulate for this, but segment RS, or the length of segment RS plus the length of segment ST equals the length of segment RT. So we get a lot of information from just a picture, right? We talk in code. So let me go ahead and erase all this and come back with the last goal, and I'll be back. I'm back for the last time, I promise. So let's go ahead and jump into our third goal, and that's going to be to bisect an angle and create equations. Remember, bisect means to cut in half or cut into two equal congruent parts. So the first example, I'm telling you that ray BD is bisecting angle ABC, or cutting in half or cutting into two equal parts. Okay? So what do we know? Well, first we know that the measure of angle ABD is equal to the measure of angle DBC. Let me learn how to write the letter D. DBC. I also know that angle ABD is congruent to angle DBC. Okay, I know that. We could add congruent arcs. And I can also write the angle addition postulate. Now, that's most likely not going to be what we need to accomplish the goal for the problem, but it's always an option, right? So I can say that the measure of angle ABD plus the measure of angle DBC. Those two add up to or open up to the amount of angle ABC. All right. So I could tell you something, and look at all that we get. Look at all these starting points, all these avenues to proceed with the problem. I have another example here. This one I'm showing you the information as a picture. Right? What am I telling you as a picture? Well, what do we know? Well, we have congruent arcs. And that means we have congruent angles. So I know that angle RUS is congruent to angle SUT. And since these guys are the same, that means that angle RUT got bisected. By ray US. I can also say that the measure of angle RUS is equal to the measure of angle SUT. And I can also say the angle addition postulate, which would be, the measure of angle RUS plus the measure of angle SUT equals the measure of angle RUT. So look at all this information we just get from the simple picture. And it's these arcs that allow me to say all of this. All right. So hopefully this helps us know how to use bisecting, what it leads to, and hopefully it all makes sense here. So I'm going to go ahead. Oh, one more thing. I had to use 3 letters when naming these angles because if I said angle B, I don't know which of the 3 angles you're talking about, or I'm talking about. If I would have said angle U, I don't know which of the 3 angles I would be talking about. So I had to name the angles using 3. If you're not sure, just use 3 letters. And remember the middle letter is the vertex. So it's always the elbow. All right, so I'm going to go ahead and end this lesson here. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.